Okay, so we're going to talk about percent problems today, and most of today is dealing with percent of change. Okay, so what percent of change is? We're going to use this proportion that says percent of change over 100 equals amount of change over original. Okay, and all percent of changes, it tells me how a value is changing in relation to the original amount. So if you go to the store and there's this big sale, 20% off, that 20% off is actually the percent of change of each item. It is changing 20% in relation to its original price. That's all that is, okay? So kind of just a different application of percents that we're talking about today. So in our problems today, we're going to be looking for either a percent of change, or we might be looking for one of the amounts, or something like that. So the big part here that kind of gets tricky is this numerator over here that says amount of change, because we have two different types of change. If we're talking about a value changing, this value can either increase or it can decrease, right? There's not, I mean, it can say the same, but that's not interesting, so we're not really going to talk about it. So it's either going to increase or it's going to decrease. So when we're talking about that amount of change, we need to talk about these two situations. Because what we're going to put in that numerator is going to be different whether we have an increase or we have a decrease. So let's start with if we have an increase. So if I have an original amount and I have a new amount, if it's an increase, that means my new amount is greater, right? That's kind of the definition of an increase, right? Your original amount is less than your new amount. Now, for purposes of today, we always want this to be positive, okay? So if I want it to be positive, the only difference between an increase and a decrease is what I subtract from what. Okay, so if I always want it to be positive, for an increase, if the new amount's going to be more, I have to take the new minus the original. Because for anything that's going to increase, that should always give me a positive number. Okay, everybody kind of following me? Okay, now on the flip side, if I have a decrease, this means that my new amount is going to be my new amount is going to be less than my original amount, right? Because it's going to go down. So the original amount is going to be greater. So this time, you just do the opposite. If you want that amount of change to be positive, you're going to take the original minus the new. That will ensure that I always have that positive number in the amount of change. Okay, now the other important part of this is the denominator over here that says over original. If percent of change is the amount of change in relation to the original, you have to put the original in the denominator. If you don't put the original in the denominator, it doesn't mean anything. A big mistake people make is they just get it mixed up. So instead of putting the original in the denominator, they'll put the new amount in the denominator. But that doesn't really give me a whole lot of useful information. If I want to be able to use this information, I need to put the original in the denominator because it's in relation to the original amount. Okay, so original goes in the denominator. Burn that into your brains. Don't forget it. Okay? Ready to try some examples? Yes? Okay, so for the examples today, we're going to have 6 of them, but we're just going to fill out a table. Okay? So we're going to build the table, and then we're going to show all of our work, and we're going to work out the problems below. So if you look at my notebook here, I have this table. So we'll fill in this table as we go, but our examples are actually going to be down here. So to build our table, we're going to have the headings. We have the original. We have the new. And then we're going to have the percent of change. Okay, and we're going to do 6 of these. So if I were you, I would go ahead and number. So 1, 2, 3, 4, 5, 6. And we'll fill this out, but we won't do our work in the table. I would also recommend you do your homework this way. It's a nice way to keep this organized so I can easily follow your work. Okay? So we're going to do 2 examples where I'm going to give you the original and the new, and we're going to find the percent of change. Those ones are pretty easy. And then I'm going to give you two where I'm going to give you the original and the percent of change. We're going to have to find the new. And then for the last two, I will give you the new and the percent of change. We're going to have to find the original. These last two are the ones that can get a little trickier, but once we set up this proportion, it's just solving a proportion, which is what we did all last week. Okay. So first one's finding the percent of change. Let's say I have an original amount of $12. I have a new amount of $15. I want to find the percent of change. Before we start, just for curiosity's sake, is this an increase or a decrease? Increase. 12 to 15, that's an increase. So maybe just make a note that this is an increase. Okay, and then let's go down to the bottom and let's find what our percent of change is. So percent of change, we need percent of change over 100 equals amount of change over original. Do I know what the percent of change is? No, that's what we're looking for, right? So we're going to put X over 100. And then on the right-hand side, I'm going to put amount of change over 100. So from 12 to 15, what was the amount of change there? $3 over what goes in the denominator? 12, because it's the original, right? We always put the original in the denominator. So if I look at this, well, this is just a proportion, right? We know how to solve that. That's what we did all last week, okay? And before I move on, just kind of make a note. This was pretty easy to find the amounts of change. You just subtract, right? But we said that this was an increase. For an increase, we're supposed to take the new minus the original. And if you look back at your table, 15 minus 12 gives you 3. Okay, so just kind of keep that in mind. Okay, so to solve this, we could go right into cross multiplying. We'd get the right answer, no problem. What else could I do? What do you say? Reduce. You could reduce. You don't have to, but it makes the numbers a little smaller. So if I reduce, I could divide out a 3, and I get 1 over 4. And now I could cross multiply. I get 100 equals 4x. Divide both sides by 4, and I should get 25. 25 what? Percent. Very good. Very good. 25%. So let's go ahead and fill that into our table. We had a 25% increase. Okay, questions on number 1. Okay, I'm going to have you guys try the second one like this on your own. Okay, so this time the original amount was $9.90. The new amount was $7.92. Okay, this time, before I let you guys off to the races, was this an increase or decrease? Decrease. This time it is a decrease. Okay, so go ahead, find the percent of change. You may use your calculators. Okay, hopefully we set up our proportion like so. X over 100 equals 990 over 792. Once again, notice we said it was a decrease. So if it's a decrease, we should take the original minus the new, which gives you 1.98 divided by the original, which was 9.9. Cross multiply, divide by 9.9. We should end up with 20, and it was a percent. So hopefully we got a 20% decrease. Any questions on the second one? No? All right. Okay, so those ones are hopefully not too bad. So we had 20% decrease. These are the ones where you have to do just a little more work, and really most of the work comes from just setting up the proportion and then solving the proportion, but that's nothing new. We've been solving proportions for a week now, okay? So this time, let's say we have an original of $790. We're looking for the new, so I'm not going to give you the new, and I'm going to tell you that it is a 12% increase. A 12% increase. Okay, so we have to do just a little bit more work, a little bit more thinking for this one. Okay, so we need percent over 100 equals amount of change over original. This time, do I know the percent of change? Yeah, it's 12. So that 12 always goes over the 100. If it's ever a percent, it always goes over 100. Okay, now for the amount of change, this is where you have to do a little bit of thinking. I know the original amount. Keep that in mind. Okay? So I have two different types of amount of change. I have an increase or a decrease. Which one is this? An increase. I told you that. I told you it was an increase. So if it's an increase, to find the amount of change, I'm going to take the new minus the original. Okay, now I don't know what the new is, though. So what do we use when we don't know something? X. So I'm going to take X minus the original, which was 790, over what? 790, because 790 was my original. Okay, so it's just a proportion. We've solved proportions like this, right? Okay, we're going to go through and solve this one together because I'm going to show you some maybe tricks that might make it just a little bit easier. So if I go through cross multiply, I have 100 times x minus 790. And then the other one, 12 times 790 gives me 9,480. From this step, there's two things you could do. You could distribute the 100, and then you'll have a two-step equation with some kind of large numbers, but really not too bad. A lot of zeros in there. Instead of distributing the 100, however, I'm going to show you something else you can do so you don't have to deal with those really large numbers. Instead of multiplying by 100, if I wanted to get rid of that 100, what would I do? Divide. And it's nice dividing by 100 because 100 or multiples of 10 just move the decimal place, right? Because if I multiply by 100, it moves the decimal place 2 places to the right. So what happens when you divide by 100? What's it going to do with the decimal? Send it back 2 places, right? So now I have x minus 790, and instead of 9,480, I'm going to move the decimal 2 places to the left, and I have 94.8. And now I just have a one-step equation to solve. So if I add 790 to both sides, we should get x equals $884.80. Okay, once again, if you want to distribute the 100, go for it, because that's what we're used to doing. But if you want maybe just a different way of looking at things, maybe in some ways could be easier. If you're not a decimal person, then maybe distributing the 100 would be better. But if you don't mind working with a few decimals, then dividing by that 100 could work too. Okay, questions on number 3? Okay, so we said it was $884.80. Okay, you guys want to try the fourth one on your own? It'll be very similar to number 3. Okay, this time we have the original price of $230. We're looking for the new, and this one is an 8.5% increase. Sorry, 8.5% decrease. 8.5% decrease. So nearly the same thing as the last one, except that numerator where you have the amount of change would be different. Okay, hopefully we set up the proportion like so. Almost the same as the last one, except this time since it's a decrease, I have to take the original minus the new. So this time I have 230 minus x. Instead of the last one, we had to flip those around. And then multiply up and across, and then once again, I like to get rid of the 100. If you would rather distribute the 100, please do so. You would get the same answer. And then you get 230 minus x equals 19.55. Subtract 230 from both sides. You're left with the negative x. I don't want a negative x, so we've got to flip all the signs. Should get $210.45. Questions on number 4? No? Doing okay? Okay, last type of problem here. Okay, so this time I'm going to give you the new and the percent of change, and we've got to find the original. Okay, so let's say for this one we have a new price of $125.40, and it is a 14% increase. A 14% increase. Okay, so there's going to be a couple things that look different about this one when we're ready to set up our proportion. Okay, first we have percent over 100, which doesn't change. That was the same as the last one, so we have 14 over 100. Okay, so for amounts of change, I have an increase, so I need to take the new minus the original. Now this time, I don't know what the new is. Sorry, I don't know what the original is. So we're going to take our new price of $125.40 and we're going to subtract the original, which I don't know, so 125.4 minus X over what? X, right? Because this time I don't know what my original is, so we're going to have an X in the denominator. So it looks a little different, but once again, we've solved proportions where we have a variable in the denominator. You still work these out the same way, so we're going to multiply up and across. So I have 100 times 125.40 minus X. That should be equal to 14X. Once again, I don't care if you distribute the 100 or if you divide by the 100. If you like the dividing by 100 thing, I'm going to work this one out that way because there's one thing that's just a little different. Make sure we understand. So we're going to divide out that 100, which moves that decimal place 2 places to the right. So I have 125.40 minus X equals 0.14X. Okay, so it looks a little different than the last one because you notice now I have X's on both sides of my equal sign. You guys see that? I have a minus X and I have a 0.14X. I need to get them all in one place. So it's easiest if I move them where there are more of them. So which side has more X's or a greater amount of X's? Right, because this is positive, that one's negative. So I need to move this over to the other side. How would you move this to the other side? Okay, add X. Now here's the thing. When we combine like terms, we're really adding the coefficients, right? So I'm going to take 0.14 plus 1, right? So 1 plus 0.14 is what? 1.14x, okay? Looks a little different, but we know how to solve those anyway. And then divide both sides by 1.14, and it should give us an original price of $110. It makes sense? Yep, so kind of the same thing, kind of different. I'm going to have you guys try the last one of these on your own. This one will be set up nearly the same way, except you may have a few things mixed around. So this time we're still looking for the original. We want a new price of $59.50, and we have a 15% decrease. So once again, just have some things flipped around. Okay, so take a second, see if you can get that one solved. Okay, so let's go ahead and talk through this one. Had percent of change over 100. Since it is a decrease, we need to take the original minus the new. We don't know what the original is, so we have X minus 59.50 over X. Once again, don't know what the original is. Multiply up and across. I divided out that 100. Once again, if you want to distribute it, please do. I think it's easier to get rid of it. And then I still have X's on either side of the equal sign. I know a lot of people like to subtract the X instead, and that would be fine as well. If you did that on the right-hand side over here, you should end up with a negative 0.85x, and you end up doing the same thing as you get here. And you should end up with $70. Okay? Questions on any of these that we've looked at today? No?